Right, thank you very much. And it's wonderful to be here. I was just musing yesterday that the very first SVPCA I attended was actually Manchester in 1985. Didn't present anything that time, of course, but Stan Westall was stood at the front speaking about early sarcopterygians from China. Anyhow, to roll on swiftly, as we don't have all that much time, terrestrialization and size. There's something funny about the terrestrialization of vertebrates. People have recognized for a long time that there are certain advantages to being small if you're going to be an incipient, sort of rather badly adapted terrestrial vertebrate. And before anybody says something, yes, I know it's an ant. But it's very small, and it makes a point. Firstly, it's much easier to support your body weight. This would be like you carrying around sort of a 6-foot piece of MDF in your teeth, you know, right? You're kind of strong when you're little. Also, it is easy to find moist, shady microhabitats if you're this sort of size. So one might expect early terrestrial vertebrates to be small, but of course, what we're actually finding is that the transitional forms that we've had until now, although somewhat variable in size, are all really quite hefty sorts of animals, leaving you wondering whether that is the true picture, in which case that's kind of interesting, or whether in fact we're missing a component. Well, it's starting to look like we're missing a component, and I'm going to show you a first glimpse of that component today. So what we have here is a little skull that my friend and colleague Pavel Beznosov collected from the Pokayama Formation along the Volga River here, right up in sort of mosquito hell of northernmost Russia a couple of years ago. It's a complete skull near enough, at least sort of complete lengthwise, there are some bones missing, with an associated shoulder girdle, and the skull itself is 31 millimeters long. So we're really talking a small animal, total body size maybe 15 centimeters. And it is associated with Bothriolipis ornata, which suggests a mid-Furmenian date. It's, in other words, significantly older than classics like Ichthyostega and Acanthostega from East Greenland, although it's not quite the earliest known articulated tetrapod. That's where it comes from. So in the approximate neighborhood of, for example, East Greenland down there, the Baltic localities down here, Zahelmia, the mid-Devonian trackway locality down there, and so on. All right, so we have this wonderful little skull. What do you do with a lovely little skull? Well, of course, you see if you can get it synchrotron scanned. And we managed to fit it into a scanning slot I had, got it done with a voxel size of 26 microns. And this is what we see. This really illustrates the power of the synchrotron because the thing's full of pyrite, and normally you think, well, that's a disaster, you won't be able to see a thing. In fact, though, the synchrotron copes beautifully with pyrite, and you get, as you can easily see here in the articular region, for example, extraordinarily good clear contrast between the bone and the matrix. The interior of this thing is three-dimensional. You can see a cross-section of a keratohyal there and so on. The problem with the specimen is that in areas that are not filled with pyrite, contrast between bone and matrix is really low, with the result that in the models you will see there are some bits that are really crisply modeled and there are other bits that are much more of a struggle. Nonetheless, we can pull out the internal anatomy quite well. So this is what it looks like in very general terms: dorsal view, side view, bottom view. We have the other lower jaw as well, I just didn't put it in. Nice basibranchial skeleton here, keratohyals, all sorts of bits and bobs. There's a brain case in there. There is down here an occipital, though it's in a terrible state, and I'm not going to say anything much about it because I don't understand it fully yet. But the ethmosphenoid in there, in kind of purple, is lovely. Palate and a collection of bones of the skull, roof, and cheek, but not everything. Anyhow, so here's our little friend. So this is then looking just at the ethmosphenoid and palatoquadrates. Ethmosphenoid very nicely preserved. The palatoquadrates not bad at all, but kind of fractured, especially posteriorly. First thing to note, left and right palatoquadrates entirely separated by this great long and fully denticulated parasphenoid. And then let's have a look. These, by the way, were Mimics screenshots. We model everything in Mimics. This is the ethmosphenoid rendered in Blender to give a more sort of subtly three-dimensional effect. All right, look at this. You've got the remains of an intracranial joint to the back. You've got a lovely big notochordal facet. You've got cup-shaped basipterygoid processes. You've got this great long parasphenoid. Basically, this is not the tetrapod ethmosphenoid. It's a lobe-finned fish ethmosphenoid, little different from Tiktaalik, and in fact, not all that different from Eusthenopteron. It's really not what you expect to find in the head of an early tetrapod. and I come back to, well, why do I think it is an early tetrapod then? I would perhaps flag one thing immediately as it's easily visible here. Look at the character of the ornament here in the squamosal, for example. All the dermal bones that have well-preserved ornament show absolutely characteristic tetrapod ornament, rather different from what you would get even in an Elpistustegid like Tiktaalik. But moving right along, this is a rough reconstruction of the palate. I mean, the proportions may need tweaking a bit, but in essence, this is what it looks like. As you can see, you have left and right palate-to-quadrate complexes entirely separated. The contrast here with a somewhat more derived tetrapod like Ichthyostega should be obvious, and you can see how this is really rather more comparable to what you have, for example, in Tiktaalik. Now, interestingly, some of you may remember that Pavel and I are also working together with Jenny on another Devonian tetrapod this is from North Timan, the other from the altogether less exotic South Timan. So it's going to be called Parmastega, and we're just in the process of kind of putting the final touches to the write-up now. It's a more kind of conventional sized tetrapod, and until now it has been the most primitive tetrapod known. I think it is fair to say. Here is the palate. This is based on very nice acid-prepared material. It certainly looks like this. You can see it's really rather similar to our little guy here. And interestingly, there are some specific similarities in terms of vomeral morphology and this curious posterior projection of the ectopterygoid, which perhaps are indicating that we're starting to see some sort of, I mean, I don't think these clade for reasons that will become clear, but maybe we're seeing a kind of gestalt here of a certain part of the tetrapod stem lineage that we haven't previously really had been able to have a look at. Parmastega is actually older than the Volga River tetrapod. It's from the very earliest Phemenian. All right, let's carry on and look at the lower jaw, and this is where things really get very surprising. As some of you know, I spent a fair part of the 90s hammering out the differences between lobe-finned fish jaws and Devonian tetrapod jaws and showing how you could identify tetrapods on the basis of a bunch of derived characters. And that's continued to work well right up until this day, but this thing has a fish lower jaw. It's got a perfectly good precoronoid fossa, little adsymphysial plate there. There's Mechelian exposure in the bottom of that. Here's Panderichthys. There's the precoronoid fossa right there, and you can easily see how very similar they are. By contrast, if you look at the lower jaw Parmastega, absolutely classic Devonian tetrapod jaw. You'd never mistake it for anything else. So it's starting to look as though we begin to break down this origin of tetrapods character complex into several steps. It seems that a bunch of the other tetrapod characteristics arose before the transformation of the jaw. Now, some of you are probably starting to mutter quietly to yourselves here, but don't worry, your mutterings will be answered. I'll explain presently. All right, skull roof. We haven't been able to piece together too much of that as yet, but we've got the frontals here, and then this item that you'd look at and think, well, those must be the nasals then. Except the fit's wrong. What's this facet for? Here's Parmastega, but in this regard, Parmastega is an absolutely generic Devonian tetrapod. Ichthyostega, Canthostega, any of those would look just the same. The edge of the frontals and the edge of the nasals just run into each other, forming basically a straight line. You don't have a step like that. But you do have a step like that in Elpistustegid, and the reason why you do, Elpistustegid, of course, is an Elpistustegid. Well, really, it is. Because here you still have a bunch of post-rostrals in the middle and little separate nasal series left and right. Chances are that that's what you have here, that this is in fact a post-rostral complex, not nasals at all. And if so, of course, again, this has never been seen in any tetrapod. So, you have all these astonishingly primitive characteristics, and yet, look at the shape of this little guy. I mean, it's sort of like a Dicerophid type thing, really. Blunt snout, the eyes are fairly far forward, broad forehead. So it's a gestalt that we just, a form that we just have not seen among Devonian tetrapods. Okay, let's look at the shoulder girdle block. This was scanned separately, but it fits physically against the back end of the skull. It's a bit of a mess. I suspect this whole specimen may be a bolus, actually. The shoulder girdle is kind of crunched up like this. Sadly, we have not been able to identify limbs for sure. There's a lot of endoskeletal stuff in there. There's the things that aren't labeled here, where the contrast is very low and modelling is really slow. So I'll have to come back to you on those. But the dermal bones come up very nicely and tell a clear story. First thing, just for a bit of fun, what the heck is that? There it is. It's very bright. It looks like it's actually coming up as possibly pyrotised soft tissue. It's obviously a midline element, non-mineralized, I guess. Could it be a sternum? I don't know. You know, answers on a postcard, please, to Puzzled of Uppsala. But the dermal bones are straightforward to interpret. You have a nice interclavicle here, cracked, but you know, what about it? With clavicular overlaps and a posterior stem. Pretty comparable to what you see in, for example, Parmastega here. If you look at the Elpistosteges, look at Tiktaalik, for example, no interclavicle is visible, presumably because it's just a little item, such as we know is present in Eusthenopteron, with no posterior stalk. So this is a very much tetrapod interclavicle. The clavicles are rather generic. Not much happens with the clavicles across the fish-tetrapod transition. They relate like that. But the clithrum is remarkable. It's slender, it's rod-like. It's clearly the clithrum. This is a dermal element. You can see that in cross-section, and with its shape and everything, I can't see what else it would be. But it means that it's really small. It's got no postbranchial lamina. It's just not at all fish-like. This looks not only like a tetrapod shoulder girdle, but a rather derived tetrapod shoulder girdle. In other words, the locomotory apparatus of this thing is transitioning to a tetrapod state. Of course, we don't have the limb bones, much less digits, but I think there's good reason to suspect that this thing had legs and feet rather than paired fins, because otherwise, why would the shoulder girdle look like this? So just quickly, then, likely phylogenetic position. This is sort of what we had until now, and it seems entirely clear to me that the Volonga River tetrapod is going to go in that sort of position, and shows us that the shoulder girdle is transformed before the brain case and lower jaw and palate. I just want to quickly flag something odd. Anybody remember this? This is a creature called Livoniana from the latest Middle Devonian of Latvia. Some sort of Elpistostegid thing, maybe, but when colleagues and I described this some 18 years ago now, we noted that it was more tetrapod-like than, say, the lower jaw Panderichthys. And in fact, it's more tetrapod-like than the lower jaw, the Volonga River tetrapod. This thing's got a big precoronoid fossa. This is nothing of the kind. All right, you know, this is actually all we have of Livoniana, and who knows what the other 98% of the animal would look like. But if we sort of stick our necks out a bit, we say, well, probably something like that. I'm with you, don't worry, I've got an eye on this. And what's interesting about that is that if that is true, then the Volonga River tetrapod represents a surviving Middle Devonian lineage, which takes us down into the time frame of these much disputed tetrapod trackway localities. I just want to wrap up by saying that however all that may be, here's a sort of head reconstruction of the Volonga River tetrapod. This is the lower jaw of Elginerpton, the earliest reconstructible tetrapod from the latest Franian, to the same scale. Look at the disparity we have among some of the earliest known Devonian tetrapods. You're not going to tell me that that does not have a prehistory of considerable length and complexity. Thank you very much.